Welcome back. We're going to go ahead and finish 2.6 and wrap up the chapter. So 2.6, solving inequalities. Our essential question today is, how do I solve inequalities involving rational expressions, and how do I find the domain of radical expressions? Okay, so the first example, we're actually going to work with some rational expressions. Here we're going to have 4 plus x minus 2 over x plus 8, actually, greater than 0. So with this one, we notice that we have a fraction, a rational expression, and I can't get rid of it because this isn't going to help me figure out the inequality correctly. It's going to get rid of critical points that I need in order to solve this. So what I need for this one is actually to find the LCD. So it's a little bit different than what we did last time. We do want to keep the denominator in this case. For this problem, our denominator is going to be x plus 8, which means I need to multiply my constant here, 4, by x plus 8 over x plus 8. So let's go ahead and do that. And then that's going to be plus x minus 2 over x plus 8, the same exact term, greater than 0. So 0 times anything being 0 doesn't change whatsoever. So here I'm going to go ahead and distribute the 4. So I get 4x plus 32. And then let's go ahead and combine the two terms because they have a common denominator. So it's plus x minus 2 all over x plus 8 greater than 0. At this point, we can just go ahead and keep on combining like terms. So I have 5x plus 30 over x plus 8, and this is greater than 0. Okay, at this point, I don't want to get rid of x plus 8. Once again, it is a critical point that I do need in order to solve and figure out which parts are actually part of my answer. Okay, so again, it's going to be an answer full of certain intervals. And what I need to do is find my critical points by setting each of these terms equal to 0. Okay, so it's going to be really nice if you can simplify your rational expression into two terms, one on top and one on the bottom. Then you solve. So 5x equals negative 30. X will be equal to negative 6. Here, x will be equal to negative 8. So my key points are negative 6 and negative 8. And once again, I do have to start at negative infinity and end at positive infinity. I'm going to go and use the chart like I did yesterday. You may test points out in between these intervals. So again, it's going to be from negative infinity, negative 8, negative 6, positive infinity. So you want to test out numbers within these three intervals. Okay, so those are the intervals we want to look at and test and see where does our answer actually lie in. So let's go ahead, set up the chart that I had. I'm going to put my numerator on top, so 5x plus 30, x plus 8 on the bottom. Set up the chart like so. Here we'll start at negative infinity, negative 8, negative 6, infinity. And then our polynomial, we're going to divide, basically the same thing as multiplying. And whatever values we get here, we'll divide them to see what values we get, so whether they're positive or whether they're negative. So over here, between negative infinity and negative 8, I can choose any negative number almost. I'm going to choose negative 10. So negative 10 times 5, that's negative 50. Negative 50 plus 30 stays negative. Negative 10 plus 8, still negative. Over here, the only whole number I can really use, or integer I can use, is negative between negative 8 and negative 6 would be negative 7. So I'm going to plug that in. This one stays positive. This one is still negative. And then over here, between negative 6 and infinity, I'm going to choose 0, leaving this one positive and this one as well. Okay? So negative divided by negative, that gives me a positive answer. Negative divided by positive, that gives me a negative answer. And positive divided by positive gives me a positive answer. So our original problem asked us for an answer that's greater than 0, so answers that will make this entire expression greater than 0, which means I need to look at my positive sections, so here and here, meaning that my answers will be negative negative infinity to negative 8, union negative 6 to infinity. Okay, so that's how you approach rational expressions. Really pretty much the same thing, just getting that common denominator will be the most important part. Example 2 is going to involve radicals. So our very good friend from last time, we're going to find the domain of the expression. Okay, so here we need to have the square root of 75 minus 3x squared, and we are looking for the domain, in other words, what x can be. Now, as we know, if we're taking the square root of something, if we want a real answer, this expression on the inside must be non-negative. And since we've been working with inequalities the entire time, we want it to be an inequality, so we'll set this as 75 minus 3x squared greater than 0. It's also going to be equal to, because you can take the square root of 0. At this point, I notice that these two have a common factor of 3. Rather than factoring it out, though, I'm going to go ahead and divide everything by 3 just to get rid of it, making it a little bit easier. So 25 minus x squared greater than or equal to 0. Here I have a difference of 2 squares, so it's going to be 5 plus x, 5 minus x, greater than or equal to 0. And again, I'm going to try to find my critical points. So I have 5 plus x equals 0, 5 minus x equals 0. Here I get x equals negative 5, and here I get x equals positive 5. So my critical points include negative 5 and 5, and then of course I also have negative infinity and positive infinity. So I do need to test out some points in there. However, there's actually kind of a shortcut to do this. I'm going to go ahead and first do it just like we've been doing. So I'll have 5 plus x, 5 minus x, set up my chart. Negative infinity, negative 5, 5, and positive infinity. So here we have our polynomial. And now I'm going to go ahead and test some points out. So if I plug in a very negative number, so like negative 10, this will be negative. This one becomes positive. Here, I'm plugging in something between negative 5 and 5, so I'll go ahead and choose 0. These two stay positive. Over here, I choose something higher than 5 or greater than 5, so this one will stay positive, and this one will be negative. Okay. These two were factors to begin with, so I multiply them together. I get negative, positive, negative. I'm looking for an answer greater than 0 or equal to, so it's going to be that one. And we're also going to include negative 5 and 5, so my interval will be negative 5 to 5. Now, if you guys think back to your parent functions as well as all these transformations, you realize that this is a parent function, the x squared, so a parabola. What you should also notice is that it was multiplied by negative 3, which means it's going to be flipped over. So it's got to look something like this. And if you're thinking about it, we need these values to be in the positive region. But I know that at some point it's going to cut off. So anything going towards the infinity directions are going to be below the 0 line. So it would have been logical to go ahead and just say negative 5 and 5 would have been the interval to choose from. However, if that logic doesn't really apply yet, go ahead and just use this table to show yourself that this would be the correct interval. Alright, so that wraps it up for Chapter 2. So we covered pretty much how to solve inequalities in many different situations. Rewind, replay as needed, and go ahead and move on to the Google Forms. Have a good evening, you guys.